part of Center of Excellence in Advanced Automotive Research, which is part of IIT Madras. I handle the translational research activities with regard to software-defined vehicles, then IoT solutions in ADAS, cybersecurity, and related areas, which are more closer to SDV basically. My background is more into I come from a communications background. I did my doctorate from IISc, and then I have been working the last 25 years in the communication industry before I moved into quasi-academic roles. So that's a little brief about me.
My name is Sriram, and I'm coming from GCC, DIC, Daimler Truck Innovation Center. We're part of the Daimler Truck group. Daimler Truck producing Mercedes-Benz trucks, Freightliner trucks, till last one, Fuso trucks, Bharat Benz in India. So all these are from the Daimler Truck family, and I'm coming from this family. Looks like he has a lot of passion talking about SDV and the toolchains. That pays my salary a little bit today. It's part of my job to do the toolchains, and so part of my job is to implement the toolchains for SDV going forward. That's what I do. I've been in the auto industry since '98, partly in US, partly in India. So that's about me. Maybe then I set a little bit of context about SDV, and then we get started. For those who have not done SDV 101, SDV is software-defined vehicles, which is, if you start looking at the evolution of automotive from crawling to walking to running, it's in the running stage. We are in the walking stage at this point of time. We all know that the vehicle is filled today with a lot of ECUs, and a lot of computation goes into the millions of lines of code and everything. We are just shifting gears to having HPC in the vehicle, zonal architectures, and removing a lot of dependency on hardware, right? So this is what SDV is all about, just to give a little bit of a review. Now, why this becomes an important topic for discussion, not only because it pays my salary, but toolchains is an important differentiator in SDV vehicles going forward. It's not just the kind of code what you write, it's the ability to deploy, validate, integrate features at a rapid pace, right? On these computers, high-performance computers on the vehicle, when it is performing on the field, is exactly where the challenge is. And that's why it becomes an extremely critical topic for everybody in the automotive sector, and so the right topic for us to discuss. So that's the context. With that, I'm going to throw a little bit of a question to Dr. Anand. He's predominantly talking, he said he will talk about the talent, so maybe let's talk from the talent perspective in India. One of the biggest thing in this tool change for SDV is how fast and how accurate you are able to develop a code and commit and deploy a code. Because it's not like you in the past where you could deploy, test and verify, and you have time for something goes wrong and you could pull it back. You are now flashing it directly on the field, I mean, it's also, pardon my ability to say this in the right way, but it's not like a smartphone that something can go wrong, right? It's a vehicle which is probably, and in my world, we're talking about a 40-ton vehicle driving at 100 kilometers per hour speed on a highway, and you can't go wrong, right? So what kind of talent do we need, especially in India, that people could do this kind of a job, to do it in the right way?
Yeah, the thing is that, as you rightly said, a glitch can actually, it could become a time bomb. Okay, so that's what is the danger that we really are facing. So we really need to ensure that this is done first time right. So there's no question of going back. You cannot take the approach of Microsoft where we will say that we first release it and then we will fix the bugs. That's not an approach we can take. Now, from a talent perspective, traditionally what we have been used to is actually, at least in India, I think probably even globally also, that's the way it has come now, probably things are probably shifting there. We have had automotives, mechanical engineering is more related to mechanical engineering or slightly oriented towards aerospace, not really so much. But what we really need is people who can develop the software or develop the code and also have the ability to think of the domain, where it is going to go, so that you need a mix of these two. So this is one part of the story. So we need to ensure that we start restructuring our curriculum where we actually bring the two together. It is happening in some places, but I think we need to really accelerate it. Because the way the technology is taking over, we don't have time to really say that, over the next 5-10 years we will be getting there, we will be starting having great courses on that. And so we really need to accelerate more on bringing these streams together. It's no more isolated islands. That's one part of it. The second part is, it's more an attitude change. It's basically, in fact, in our previous panel discussion also, there was a reflection on the quality. Okay. Yes, we are there. India does produce very, very good quality products. It is not that even. The classic example is our success in the spacecraft. Okay. No country is anywhere near close to what India has achieved with respect to the satellite launching vehicles, the success rates. So, which means we do have it in us. But we need to make that happen more often. That's basically that everywhere people should start realizing that it is not a compromise that you could make on quality. It's something that quality is taken for granted, and that has to be inbuilt, and then you look at what is required to be done. If you were to achieve that level of quality, you work back. But we always do the reverse. We first do everything and then we start validating, we put it through testing, and then we say, oh, there are so many bugs we will fix. Oh, the schedules are not permitting us to fix everything, so we will release with the bugs. So that is point number 2. The third thing is, whatever we do, software is a kind of a monster where it is extremely difficult to say that you have a perfect software which is bug free. So how do we use more of digital methods? Can we use digital modeling, etc., and ensure that whatever we develop, so the validation also happens in the digital world before we get into the physical world, so that we are a lot more confident with what we have designed, and then look at how we can, that's something that could enhance the quality and help towards moving towards first time learning. So we have to use all these 3 techniques, and probably a lot more, where we ensure that focus on quality is not compromised at all. That's my take.
You're saying it's not a rocket science.
Yeah, it's not a rocket science. We have to borrow a lot from the rocket science though. So basically, if you look at this, there is a lot of, when we look at the flow, we talk about software being developed, and that development happens probably in a GCC, you said. Okay, but the real deployment happens from the OEM's side, and it is deployed on the vehicles, which is actually dynamic, it's moving, and so there is a lot of complexity. So basically, we have all these FOTA, all these frameworks are there, which is there. Our traditional DevOps mechanisms, the CI/CD, all those things actually have to be, we have to cater to the OTA fitting into these traditional CI/CD flow. Being a tools expert, I just wanted to want your thoughts on how do you see actually in these kind of changes that would be required in making this happen more smoothly.
The biggest challenge is we are not starting with greenfield approach, right? Everything is already existing. We are using a toolchain. We are using some kind of methodology. If you ask somebody what do they use for gathering input, they will tell you a old IBM tool probably, which they are used to, and it works, right, for somebody to do the requirements gathering. Then if you ask somebody how do you do issue tracking, they will tell you, yeah, there is an industry standard which we use, maybe called Jira for somebody else is using something else, and so on and so forth. Now the biggest challenge which we find is for those people who are into the vehicle software development space, you understand the V cycle, right? From the requirements gathering to development to validation to deployment. And if you look at this V cycle, this is not interconnected at this point of time. That's the biggest problem. And what we would like to do then, we are of course doing something or other today. Like I said, we are in the walk mode right now from crawl. So we are already facing a lot of these challenges, and what we end up doing is we end up doing a lot of patchwork. We connect these toolchains somehow by plugins and whatnot, and we do these patchworks. But that's something which is not going to take us too far, because the speed at which the deployment has to happen in the future is something which you will lose with this. The second point is the traceability of data. Today, data is not 100% traceable. Now, let's take the case of a service technician doing diagnostics on a field in a vehicle. You take your car, it's already there, and they get data, and now they want to say that there's something wrong in the ECU, and they want to update it. They go back to the OEM, and by the time it reaches the engineering team, which is in the OEM, this has to go through multiple cycles, right? There is no clean, direct traceability of this information. And so what happens is you're, as a customer, having to wait a long time for an update to come. And these are the things which we want to get over with in the future when you are able to flash over there or whatnot. But then for that we need a clean data, a pipeline, and traceability of information. So this is the reason why everybody is slowly tending to go towards these kind of application lifecycle managements, right? How I could start with the input gathering to issue tracking to documentation to design to how you commit the codes to release and everything. So this is becoming more and more important to have seamless approach. Yeah, and efforts are in this direction.
Kind of flashing and all these things around. One of the things which comes to my mind, one of the challenges that we often have, you're actually going to be upgrading the software, particularly when you're flashing the image. Basically, that image is actually going to be upgraded, and when we are talking about the CI/CD thing, that actually the development is developing the software and then it is just pushing the software over to the production environment or production final thing where it is going to reside on the vehicle. Whereas when you really flash it, you really need to identify what time you are going to be flashing it. You cannot actually, the timing of it, like when the vehicle is in motion, you cannot obviously do it, because more and more of the critical controls are all now being driven through the software. So how do you actually see some of these CI/CD process itself shifting, or what challenges do you see in actually implementing this vehicle?
Yeah, that's already a challenge today, not only in the SDV world, right? We already do OTAs, FOTAs especially, not everything in OTA. Let's take specifically FOTA, flashing. It's not like you just flash a smartphone on the go and you just hit the update button and go. You don't get that option. There is already partitions in the ECUs. The flash files are stored in this partition A or B, depending on the way the ECU is configured. And what happens is there's of course routing return to say that when you are in a park mode, then there's an option given to the driver, they could do it, or if there's a fleet manager, they could do it. This is already a challenge today, because sometimes, like I just mentioned it, it's like, unlike a smartphone, you can't flash it on the go, right? Every ECU is critical for the functioning of the car, and nothing can go wrong while it is functioning. Now, the difference comes in SDV is we are now talking about feature updates, and we could do a lot of feature updates over the air. And this is the biggest advantage of the SDV. And like we said, we could call it an iPhone on wheels, right? A vehicle could be called an iPhone on wheels, that you could keep flashing new features, and if you on-demand features could also be updated while you are on the go, which again has to be done in Spark and everything like that. But because it's feature update, these partitions on the HPC will still remain, and there will be a place where this is also in case of rollback. If the flashing phase, you need the partition to go back to the old existing software. But the feature becomes much more faster to update in an SDV world than today's world. And that's the biggest differentiation coming from today's world when you go to the SDV world. That brings me to a question which I want to ask you. We are going away from being hardware dependent in SDV, right? And especially in GCC world, we do a lot of work for Germany, US, Japan, France, whatnot, right? The question I have is, since we move away from being hardware dependent in SDV and more software dependent, you could do a lot of virtual validation, civil, hill, whatnot, which means you could move a lot of work in these spaces to India, because India has very good DevOps talent, very good digital talent, AI mindset, whatnot. Quality is significantly improved over the years. I can see that people are starting to think through the solution end to end. This is all happening right now. Right? Tell me, do you see from academia side that are still a lot of these things headquarter driven, or are they able to move ownership to India to say that, okay, now you decide on how you want to make this platform happen?
Before we really look at that question, explore it from whether how the ownership resides or where it resides. When you talk of ownership, the first thing that you really need to have is that you need to have the capability, the credibility to really own it. So have we established that capability? Have we shown to the parent organization with the quality or with better quality that we can do? Though we say that, okay, India is, we have all these things. Now they need to be, it's not about being 100% certain that we will be able to do, they need to be probably 200% certain that we will be able to do, and we can do it better than what they can do. So that kind of a thing is what is probably blocking us from really getting there. We tend to, sometimes I feel, I mean, it may not be, I don't want to generalize it, but sometimes I feel that we tend to actually try a few times, and then when it fails, then we just say that, oh, the parent organization will not allow me to do it. But we have to reflect on what exactly are they really looking at. Of course, there might be other geopolitical reasons and all those stuff.
Yeah, but when I see people or kids graduating from universities in Germany or US, they seem to have this capability right at the beginning. And what is missing in our curriculum that we are unable to do that?
Right. That was actually one very important thing, the difference that we see here. In our system, education is still, there is a significant gap that exists from the industry. So there is a need to actually bridge this gap. So in fact, this gap is existing in two ways. One is basically the graduates that you said coming from the academia are not ready. So they need to go through, and then the company is not, they cannot invest all their time and effort to bridge this gap. They do a quick bridging. So some quality is lost there. Okay, capability, there is some kind of a patchwork is being done there. So that the skilling, the real education, the whole system should be more oriented towards building a strong foundation, and at the same time using that foundation to skill the people. It's not about just skilling the people like what a polytechnics will do. Not about building the technicians, but also they should be having the engineering to do it. So you need the platform, the theoretical background, the foundations that go into it. But at the same time, they should be people who are ready to get their hands dirty very quickly. I know so many engineers who come out. When we ask them to do very simple tasks of, say, changing a light bulb or fixing a small thing in the tube light or something, they don't want to do it. They would rather call the electrician to do it. So that reluctance is there because they have not got their hands dirty with it. That's it. It's not that they don't know. They know how to do it. They don't want to risk it. So I think we need to focus more on do things and learn as much as we are focusing on the content delivery that happens in colleges. So that shifting has to happen. We do see some things happening in at least some of the likes of the IITs and NITs and some. So basically certain things are happening, but still I would say that it is still restricted to a few institutions, or maybe it is probably happening in limited sense even in those institutions. So that is one of the reasons why that credibility, building that credibility is not so easy. It's not happening so easily for Indians.
Yeah, but when we shift ourselves in our cars in the future with some of these new technologies, you would see that happening. And how does that happen as well? That's also a relatively interesting thing for me to understand. Why does that not happen when you are not in the lead or when you are in the lead? There's a difference, right?
I think there is still some gap. I mean, from curriculum, I don't know, maybe I'm just speculating there, how to what extent we are actually involving the industry to design some of these things. And It is not about just, see, actually I have been in curriculum committees in the past and in the Senate committees. What I have noticed is that there is a lot of weightage is more on the academia. You have people more from academia filling these committees, and there are a couple of representatives from the industry. When the industry suggests something, it is very easy for the academia to overpower them and override them, saying that no, this is the way we have to do it. I have seen that kind of discussions happening. When I suggested something, some change, immediately some people will jump on it and say, no, we cannot teach like this. This is the way we have to teach. Well, if that is the way you have to teach, then I have to back off, because I'm not an academician. At least at that point, I was not at all. So I have to say that okay, I'm an inexperienced thing, but there is nobody to back me up in that scenario. So I think the reason why this curriculum committee, these senates, and all these things are there is that actually an industry should be more appropriately involved there to design some of these activities. It's not about just designing the courses or the curriculum at the course level, but what is being done in each of the courses. How do you really deliver these courses? How many institutions really go down to relooking at the delivery itself? It's not about just having 40 hours of lecture. Why do we need 40 hours of lecture if it is going to be something? Can we change it to a 2020 model? That they get to do something in 20 hours. So I think all these restructuring has to happen, and there is a lot of baggage that we have been carrying along with us. So that shift has to happen. And in my perspective, that can happen only when you start bringing in industry involvement in academia more, significantly more. And academic and industry also should be taking it up as their responsibility as delivering back to the society. It's not about, I don't have time, so I don't want to spend more than 1 hour on all these things. So you quickly do all these things, I'll come, sit and sign some papers and go off. That is also a problem that I've seen. Not everybody is involved. We do have, for example, in our own board, we do have some people from the industry, but we get very little time of there, very little time. So whatever time we get, we want to ensure that we optimize their usage.